All right, I thought I'd make a quick video about dividing polynomials. This is something that often gets sort of whizzed through in Algebra 2 or Pre-Calc. There's a couple different strategies. Not everybody sees all of them, and it can be confusing. So my goal here is to try to simplify this function that I've got up in the top right corner. And the first strategy I'm going to show you is just basic long division. And I don't know how many of you remember long division, to be honest with you. Since I'm a high school teacher, I don't even know if they still teach long division. But long division looks like this. And what we do is we start by saying how many times does 2x go into 6x cubed? And we know that that's 3x squared times. We're only looking at the leading terms. So in long division, then what you do is you multiply your 3x squared by the whole divisor. So what I get now is I get 6x cubed plus 15x squared, and I subtract. The 6x cubes obviously cancel out. 7x squared minus 15x squared, I get negative 8x squared. And then I bring down the next term. And I repeat the process. Change colors. How many times does 2x go into negative x squared? And the answer is it goes in negative 4x times. Multiply the whole divisor, and I get negative 8x squared minus 20x. I subtract negative 8 minus negative 8 is 0. Negative 16 minus negative 20 is 4x. And I bring down the next, and in this case, last term. Doing this one more time, how many times does 2x go into 4x? It goes in 2 times. I multiply and I get 4x plus 10. And notice that in this case, I have no remainder. Well, that's actually sort of nice, because what this tells me is that I can now write my function as f of x equals 2x plus 5 times this quadratic, 3x squared minus 4x plus 2, all divided by 2x plus 5. And I know that this function is going to be a quadratic with a whole at x equals negative 5 halves. So the second strategy that I'm going to use takes advantage of the fact that when I look at this function, 6x cubed plus 7x squared minus 16x plus 10 divided by 2x plus 5, I know that that means that I'm going to be able to write it as 2x plus 5 times some quadratic, assuming it is evenly divisible. So I'm going to draw a generic rectangle, and I'm going to say that, well, if I were to multiply 2x plus 5 times my quadratic, I would get 6x cubed plus 7x squared minus 16x plus 10. That means that this cubic has to go into the generic rectangle. Well, I know that the 6x cubed is going to go here, and I know that my quadratic must have 3x squared, because 3x squared times 2x equals 6x cubed. Well, now I can multiply 3x squared times 5, which gives me 15x squared. And I notice that I need 7, but I have 15, so I have to have a negative 8x squared there. Well, again, this tells me that this has to be negative 4x. Multiplying negative 4 times 5, I get negative 20. I have negative 20x in my rectangle. I need a total of negative 16, which means that this has to be a plus 4. 2 times 2 is 4x, multiplying down, plus 10, and there's my check digit, tells me that yes, in fact, this goes in evenly. And once again, and I'm sorry for the colors having switched back and forth randomly, I just forgot to keep changing back. There's the result of my division. This is called a generic rectangle for those of you who haven't seen it before. And the big thing to notice on the generic rectangle is that the diagonals have to add up to the quantities in your numerator of your division problem. Hope that helps. It's a quick review. Sorry if it's not in enough detail, if you haven't seen it before, but this video is really designed for people who've seen these before and just wanted a quick refresher. Have a great day.